Hello, discrete math fans. Let's say I have a sock drawer. It's full of white socks and black socks. And in the dark, you're going to pull out socks until you have a matching pair. How many do you need to pull out until you are sure that you have a matching pair? Well, the answer is you need 3. If you pull out 3 socks, you're guaranteed that you have a matching pair. What you want to do is think of the socks as the pigeons and the colors as the pigeonholes. There are only 2 colors, those are the pigeonholes, and once you have 3 socks, pigeons, then the pigeonhole principle guarantees that at least 2 of the socks will be the same color. Now, as you work through pigeonhole principle problems, you always want to make sure that you identify what in your problem represents the pigeons and what represents the pigeonholes. Here's another example. You have a town with 400 residents. Do you have to have 2 residents who share a birthday? And when we say sharing a birthday, we're talking about being born on the same month and day, not necessarily the same year. The answer is yes. 400 is bigger than 366. The residents are the pigeons, the possible birthdays, 366 of them, are the pigeonholes. Here's another one. Let's take a 5x5 chessboard. And at every square, there's a flea, a little insect. At the same instant, all the fleas are going to jump. And when they jump, they're going to jump to a neighboring square. Now, you can't do a diagonal jump. You can only move one square up, down, left, right. Now, is it possible that after one jump for every flea, that there will still be exactly 1 flea per square? The answer is that it is not possible. Let's explain why. Let's color our chessboard like a chessboard. Looks like this, alternating colors, white and dark. There's 13 dark squares and 12 light squares. So whenever you have a flea that jumps, it will jump from either a dark square to a light square or vice versa. You have to change colors. No diagonal moves allowed. So when we start, and there's 1 flea on each square, that means there's 13 fleas on dark squares, and they all have to jump to a light square. But there's only 12 light squares. So, according to the pigeonhole principle, after the jump, there's going to have to be at least 1 square with 2 or more fleas. So I think in this case, we're thinking of the pigeons as being the 13 fleas that start on dark squares, and the pigeonholes are the 12 light squares that those fleas are going to have to jump to. Okay, that's all for now.